Hello, and how's it going? Just for fun, I thought let's play around a little bit with old OpenGL, Legacy OpenGL. I'm not sure what your experience is, but back in the day, this is actually how I started. I was using Game Maker, and we had the equivalent in Direct 3D, D3D begin, primitive end, all that sort of stuff. But anyway, look, today the topic is going to be very simple. We are going to get a wireframe cube on the screen, and I'm also going to investigate the way OpenGL or Legacy OpenGL handles transformations. We're going to do this all in Python. We're going to do this with Pygame and PyOpenGL, and we'll get to it as we go. But before we get into it, I just want to basically set out what we're going to do. So I'll draw some axes. Okay. So imagine that we have, well, let's put our camera here at the origin for now. And imagine that the camera pretty much lines up with our screen. So from left to right, we have the x-axis. And the y-axis is top to bottom. And I'll just put some little marks here. So positive x is to the right, negative x is to the left, positive y is up the top, negative y is down the bottom, and our depth, how far we are sort of out in front of us, is our z-axis. Now the convention here, it follows the right-hand rule. So if I were to take my fingers and rotate from the x to the y, my thumb would be pointing back at me. So positive, even though like a positive depth I would imagine would be out in front of the camera, it's actually behind the camera. And what can I say there other than OpenGL is strange? I'll say that many times. OpenGL is strange. Let's say we want to put a cube out. So what I'll do is I'll just quickly... Actually, this might be... Okay, I'm going to redo this. Following the same sort of convention. So just imagine that our camera is somewhere else. I just want to get the cube centered because it will make it a little easier to visualize. Okay, so here we have our origin, and we'll just sort of draw my cube out here. A little hard to see, a little wonky, but we'll go with it. So I'll just label these positions 0, 1, 2, 3, and then 4, 5, 6, 7. Okay, so if I were to look at the coordinates of position 0, we are in the positive x. I'll go with an x of 1, a y of negative 1 because they're down the bottom, and a z of positive 1. And then I'll pretty much do the same for all the other points. Okay, I think I did that properly. Little messy, but that's okay. So these are my points. But what I want to define, because I'm going to draw a wireframe, is I need some idea of the edges. So for instance, if I look here, I've got an edge which goes from point 0 off to point 1. And then likewise, I've got an edge that goes from point 1 to point 2, and then one from point 2 to point 3. You can see where I'm going with this. So what I'm going to do is I'm going to basically write out all of the corner pairs. Okay, so those are all my pairs. Now just for simplicity, I've grouped them a little bit, so you should be able to see. This won't be reflected in our program, but just as a check to make sure it makes sense. So we've got these edges are defining sort of the bottom of the cube, these edges are defining the top of the cube, and these other edges are filling in on the sides. That's the geometry of our problem. Let's go ahead and code that up. Okay, so here we are in Visual Studio Code. I've just got some random folder open. We can do this anywhere, it really doesn't matter. I'll go ahead and make a new file, which I'll call, again, completely arbitrary, just a Python file, main.py. I'll go ahead and select my interpreter, which in this case is Python 3.12. I'm just going to assume that we are coming in completely from scratch. The first thing I'm going to do is I'm going to define a set of vertices. I'm going to use a tuple of tuples because tuples are immutable, they can't change, and I don't want my vertex data to change. So I'll just be 1 second here, I'll just write in what I wrote on the paper. So here, this is a single point, and I'm going to go ahead and write in all of my points. There we go. I'll just neaten things up a little bit. Whoops. Neaten things up a little bit for visual purposes. Not that it matters that much. There we go. Excellent. So that's my set of vertices. The next thing I'm going to define is my set of indices. And I'm going to define these, actually I'll go ahead and call them wireframe indices. Why not? And I'm actually going to define these as my edges. So for instance, I've got an edge which goes from corner 0 to corner 1. That's my edge. Then I'll go from corner 1 to corner 2. Now there are tricks I can use to reduce the repeated indices, but I'm just going to go with this for now. It's not going to win any awards for aesthetics, but it is correct, I think, at least in terms of what I wrote. Okay, so come on. Hey. So those are my data sets. Now I need to draw the data sets. So I'm just going to run through the libraries that I'll need. I'll pretty much need Pygame and PyOpenGL. If you don't have those, no problem. We can just, I'll quickly go through this. So create a terminal, and we'll need something like pip install Pygame. I use Pygame Community Edition. In this case, it says that I've got Pygame Community Edition. Now, I have seen in the past a number of issues, and one really common one is that we'll have some Python interpreter version. Over here it's Python 3.12, but then when we get this message that we've already installed this package, it may install to a different Python version. And there are ways to mitigate this, to fix this. If you get this issue, one sort of rubber mallet which fixes it no matter what is I pop in here, I search for Python, and I've got this executable, this Python executable. I can just right click, open file location. This is a shortcut. The point here is that I am trying to get to the underlying location here. So what I can do is I can copy this location of the Python executable, and then I can pop in here and say change directory to that location. And then in here, I'm going to run Python, pass it a message to pip install Pygame's Community Edition. Just like that. And you can see it does the same thing, but this is an example of how to be really explicit. And I'm going to get rid of that. So there we are, just where we are again. Okay, cool. So we've got Pygame. So I'm going to go ahead and import that. So I'll go import Pygame. I like to give it an alias, PG. And the next thing I'm going to need is PyOpenGL. So again, it's pip install, very careful with the capitals here, PyOpenGL. And again, it says, hey, you've already got it. Awesome. So I'll just close that down. Now what I'm going to need is I'm going to need basically all the OpenGL stuff. So I'll say the graphics library within there. import everything, and also there's GL utility, which has some convenience functions and things. I'm going to use that as well. All right, so I've got my data defined. What I'm going to do is I'm going to make a function which will draw the data as a wireframe. So I'll define a function called draw wireframe. Okay, I'm going to take in my set of vertices and my set of indices, and that'll be it. If you look in the finished code in my GitHub repo, I have type hints and things, but I'm just trying to keep it really simple at the moment. So what I'll do is I will begin drawing, and the mode I'm going to draw in is lines. Now the way that line drawing works is for every two things that are thrown at this, they will be formed into a straight line. So every pair of two form a line segment. That's how this is going to work. So what I want to do is look at each index. So I'll say for index in indices. So index will be a temporary variable going one by one through each of these things, basically. I will define vertex 3 float vector So I'm using the index to literally index into the set of vertices, pick out the appropriate vertex, throw it at the graphics card. There we go. That's our drawing function. So with that out of the way, I'm then going to set up everything pretty much. So I will initialize Pygame, set up the screen. So the way this works is we pass in a tuple, which is the size of screen that we are requesting, and then we can put in some flags. In this case, I want double buffered display. Why not? And I'm also going to specify that I want an OpenGL display. And this will create, well, it'll basically initialize OpenGL for me. I'm also going to, just to control the frame rate, I'm going to create a clock. We'll use that later. And then I'm going to set the perspective projection. So this will be done with GL utility. There we go, perspective. And all I need to do there is pass in the field of view angle in degrees, 45 degrees, and then the aspect ratio as width over height, and then the near distance and the far distance. So anything closer than 0.1 units will not be drawn, anything further than 50 units will not be drawn. I'm also going to add a translation, and this translation is going to move everything back away from me. Remember at the start of the video I said the camera is at the origin? It really is at the origin. What I want to do is take all of these points and shift them away from the camera. So I'm going to go GL, translate float. And I'm not going to shift in the X, I'm not going to shift in the Y, I'm just going to move everything back by 5 units. Remember that a negative Z, let's minimize this for now. Remember that a negative Z is far away from me. It's strange. OpenGL is strange. Then we're going to set up my, whoops, what's that? I'm going to set up my main loop. Okay, so currently we are pretty much doing nothing. That's okay. But we have this event here, which is a quit event. So if I were to run this currently, hopefully it works. Yeah, we've got a window. It's doing nothing. If I click quit, then we get a quit event. and everything wraps up. So what I'm going to do is I'm going to spin my cube around a little bit, and I'll do that with GL rotate float. We need to pass in some arguments. We have the angle, and then this x, y, z is the axis around which we're going to rotate. So for instance, let's say that I just want my cube to spin around the y-axis, so it will look like a horizontal spinning. I'm just going to spin it by 1 degree just around the y-axis, like that. Now let's go ahead and pass in the data, what is that, wireframe indices? There we go. I'm also going to need to do a few things. I'm going to need to update the display. So I'll go Pygame display flip, because it's a double buffered display, we flip it around, and then going to update the clock, and I can also put in a required frame rate. So this will be locking my frame rate to 60 frames per second. Cool. So give this a spin. Literally, right? It's spinning. It gave it a spin. So we can also pass in an arbitrary axis. So let's say, for instance, that I want this thing to spin in the X, Y, and Z axis. Actually, yeah, we'll do that. X, Y, and Z. Little strange, but here we go. It's spinning in the X, Y, and Z axis. Awesome. So there's one thing which is a little strange, and that is that these transformations seem to be cumulative. Like it seems that every frame I'm rotating just by 1 degree, and then it accumulates those transformations. All I need to do is every frame just tell it to rotate by 1 degree, and it does that. And that's fine if I've only got one object in my entire game. But how do we reset transformations and set transformations for individual objects? This is a little more complicated. I'm going to pop back to the paper and investigate. Okay, so what we've been doing so far has been all right. We can define our data, we can draw it, we can continually rotate the data around, but this is not really a completely rigorous way of working with transformations. The way Legacy OpenGL handles transformations is with a matrix stack. So let's say that I want to apply some sort of transformation. What I do is first I push a matrix onto the stack, and then this becomes the current transformation for the matrix. I do whatever I need to do to that transformation matrix, and then when I'm done, I pop that off the stack, and that resets the transformation, so that then when I go to draw another object, I push onto the stack, apply a different transformation, then draw the object, and then pop it off, and I can draw another object. And this may seem a little strange and illogical, and I'm tempted to say OpenGL is strange, but there is actually a use case where this is really handy, and that's with transformation hierarchies. Consider the transformation on the right. When I go to draw the body, first of all, I'll push a matrix onto the stack. That's the current matrix that I'm working with. I do all my transformation stuff, but then when it comes time to draw the left thigh, there's a behavior that happens when we push onto the stack. And what happens is that when I push onto the stack, this next matrix which gets pushed on is actually, a clone of the last matrix on the stack. So when I go to draw this left thigh, pushing onto the matrix stack, I inherit all of the transformations which were previously set for matrix 0. Then I go ahead, let me go through this full hierarchy. So I go, okay, I'm done the left thigh. So now I push on again to draw the left calf. And then that left calf has a child, so I'll push on again to draw the left foot. The left foot does not have any children. So what I'll do is I'll pop, and then just say for argument's sake, I don't know why this would happen, but let's just say we have some other object attached. Okay, so I've done the left foot, pop that off, and then I want to apply something to the left calf. So I'll push on again, and again we inherit all the transformation which has occurred up to this point from the stack, and then I can go and put some more specific transformation on here. But again, let's say that that's done, so we go, okay, we're done here, we're done here, so we push off, pop off, pop off, and then it comes time, because body has another child, I want to do something for the right thigh, so I'll push on again, and again I inherit that body transformation because that was already there on the stack. So in matrix 1 is a clone of the body, and then I put on my specific transformations here. So this was all made with a scene graph in mind. A scene graph is a hierarchical representation of a scene where objects have children and things. So yeah, hopefully this has demystified the matrix stack. Now let's go in and play with that for a little bit. So with that in mind, we've done that now. I'm going to actually model my cube as an object. So I'm going to give it some angle, and then every frame I'm going to increase that angle. So I'll increase the angle by 1, and then I'll just check if we're bigger than, oh, it would be fine, it would be totally fine, but I'll keep it in the bounds from 0 to 360 anyway. There we have it. Okay, so now what I'm going to do is I'm going to modify this draw wireframe so that it also takes in the angle that I want to draw at. I'm going to take this rotation, boop, and I'm going to put that rotation into the draw wireframe function. So up here. So what I'm going to do is, instead of rotating by 1 degree every frame, I'm going to rotate to an angle of theta, but this will be a problem. Actually, let me go ahead and run this. You'll find that it sort of accelerates. Yeah, really, really bad. And I'll make this even more obvious by increasing by a very small amount. So you'll see that, yeah, because I'm stacking on, continually modifying the transformation, this is actually accelerating the speed up. And that's not what I want. I actually want to rotate to that angle, not by that angle. And so what I'll do is, just as I was saying on the paper, I will push on a new transformation. That gives me a new matrix to work with, and then I want to remove that cumulative effect, so I'll pop that matrix. And so every frame when we go to draw, we push on a new matrix, get it to the angle that we need it to be, and then reset the transformation matrix. And there's maybe one more thing that I want to make super explicit. GLU actually does a pretty good job of setting this under the hood, but to be super, super explicit, I'm going to set the matrix mode. So there's a bunch of matrix modes. There's projection, and yeah, so we can go, yeah, we can go GL projection. That will set this to modify the projection matrix, but I'm actually going to set this to, yeah, model view. And so this explicitly sets it so that every transformation that occurs beyond this point will be happening independent of the perspective projection. In a future video, I'll be investigating the differences between these things, but there we have it for now. So I'll just step through this super quickly. Today, we drew a wireframe cube in Legacy OpenGL using Pygame. We investigated the matrix transformation stack, which allows us to do more general transformations. And hopefully this has given you like a cool little thing that you can build on. But yeah, I mean, is that not cool? I think that's very cool. Okay, so I hope that you had fun, and I will see you again at some point. All right, bye.